Good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing this evening will be on how to vary the speed of a DC motor by using a DC speed controller. Okay, this should be the DC speed controller. And this is my switch mode power supply. So I will be using one of the voltages here to inject to the input of the DC speed controller. Okay, this one here, coming from this. And the output of the DC speed controller is this one here, the one on the right. And I make some connections here. This is the positive terminal, the one that came from the speed controller. And this is the negative terminal. Okay. So to produce or to show you how we vary the speed of this one, I connected an ammeter in series with the positive terminal of the DC speed controller to monitor the current consumption of this DC motor here. DC motor, it's a DC fan. This DC fan here is actually 12 volts. Actually, to vary the speed of this DC fan here, we must have to adjust the current. Okay, adjust the current consumption of this one without changing the voltage. So what we are varying here is actually the current consumption of the motor. Okay, but we maintain a constant voltage because the voltage will be, if you try to increase the voltage to a greater than, like this one here, it's 12 volts. You could increase the speed of this one by increasing the voltage, but you might burn the motor. So the proper way on how to do that is actually maintain the desired voltage of the motor, just increase the current. And to increase the current, we must have to use this DC speed controller here. And that DC speed controller is actually this one here. It's a variable resistance in which if we try to rotate this one, we either increase or decrease the current going to the DC motor. So right now, the switch mode power supply is actually plugged in now. Okay, but the motor is not yet running because I haven't activated the DC speed controller. This DC speed controller is this one here. For this to be activated, we will rotate this one clockwise. And when we rotate it clockwise, okay, we are actually placing this DC speed controller on the on position. Okay, let's try to do it. I will now try to push this one. We could hear a click. Okay, and as you could hear the click, right? An LED was lighted indicating that the power for this one is already ready to activate any load connected at the terminal. This is the terminal for the load, and our load is actually the DC motor, the DC electric fan. How come the motor is not yet running? It's on already because at this position, at this almost 2% position, the voltage is still very small. Okay, we'll try to rotate this one. And if we try to rotate, okay, the motor is now starting to run, right? But it's very slow. It seems it is on slow motion. I will increase the rotation of this controller here a little bit. Okay. the running of the DC fan is actually very smooth. And the current consumption at this rotation is actually 0.078 amperes. If we would like to increase the speed of that motor, again, we will try to rotate more this controller in the clockwise direction. Okay, you could hear that the motor is murmuring a little bit, meaning it's accelerating. And as you can see it, the current consumption is 0.103 amperes. Okay, I will try to rotate more the controller in the clockwise direction to increase the current. Actually, to increase the current, we will rotate this one clockwise. And you could hear the murmuring of the DC motor a little bit louder. And as you can see it, the current consumption now raises to 1.123 amperes. Okay, I will try to increase more. As we increase more, the rotation will be faster and the current will be greater, actually maintaining the same voltage emanating from this one. Okay. Okay, the murmuring grows louder, and the consumption now raised to 0.141 amperes. But as you can see it, the rotation of the DC motor is actually very smooth. Okay, it works good. Okay, I will try to maximize the speed. That's the maximum speed that we could handle, that we could bring out. Okay, you can see it. And the maximum current at this maximum speed is just only 0.155 amperes. Okay, so this is an illustration on how to vary the speed of the DC motor by using a DC speed controller. Okay, of course, the DC speed controller needed a what you call this stable voltage input. And my voltage input is actually emanating from my switch mode power supply. I just use one terminal voltage, the 12 volt, because this switch mode power supply got many output voltages. It got a 5 volt, 3 12 volts, and 2 5 volts. Actually, if we would like to increase more the current for this DC fan here, we could actually connect these 3 12 volt here in parallel. So the current will be, since they are in parallel, it will add up to the current that will be giving off by this charge controller. But for the meantime, I just use one. Like what I said, if we would like to increase more the speed, we will connect this 12 volt and 12 volt again in parallel with the first one. Okay, we could do that. But we don't need any more higher rotation than this one. We are satisfied with the rotation of this DC fan here, because the significance of this DC fan here is while you are doing your troubleshooting and you feel hot, that will be the use of the electric fan here to cool you off. And one thing more, while you are soldering, if you got a DC fan, right, blowing to your face, okay, you will not be inhaling the smoke coming from the soldering gun, because that smoke is actually toxic, you know. So it's a must that while you're having your soldering and there's a smoke coming from the soldering gun, okay, you should use a DC fan to blow that smoke which is toxic away from your face. Okay. Okay, I will show you how to, we will, what you call this, decrease the speed. If we try to decrease the speed of this one, we will rotate this one counterclockwise. Okay. The current now dropped to 1.149 amperes, and as you can see it, the rotation of the DC fan is actually decreasing. One more. It's 1.127. Still, the rotation is not so slow, but you can see that if we try to rotate this one counterclockwise, we could see that the motor is slowing down. Okay, I will try to increase this one a little bit. So you can see this is slowing down already. Okay, 0.111 amperes, 0.1 amperes, 0.090 amperes. It's still rotating, but you can see that the rotation is not so fast, right? That's why this is the so-called DC speed controller, right? And I will try to make the current zero. It's almost zero. 0.045 amperes. You can see that the electric fan is still rotating, but it's slowing down already. And if I want to shut off the DC fan, I will put this one to zero. The current consumption now is zero, right? Current consumption is zero. The motor has stopped. Still, the voltage here is still 12 volts, but the current for the meantime, due to this controller, is zero. That's why the motor is not running. There could be voltage here, but if there is no current coming out due to the DC speed controller, the motor, the DC fan will not rotate. Okay, I will try to make the DC fan again live. I will rotate this clockwise. Okay. It's alive again. The current is just 0.1 ampere. More. Okay. More. More. The motor is accelerating, right? It's accelerating very fast, and the feeling of the air blowing out is very nice, you know. You feel comfortable from it. You can see it, guys? So this is the significance of the DC speed controller. If you don't feel comfortable with the speed of the fan, okay, you could increase or decrease it depending on what you want. Okay, I will try to maximize it. That's the maximum speed now. If the input voltage is just 12 volts, okay? But if I will try to connect 3 12 volts in parallel, the speed will be greater, you know? And again, I will try to make this one go to stop operation. The motor now stops, and the current is zero. Okay, good evening from Los Angeles. This is Professor David J. De Los Reyes. This is the concept on how to vary the speed of the DC fan using a DC speed controller. But what you call this, the needed things for this to operate is actually the input voltage. There should be a reliable input voltage. And the input voltage is very reliable because this is a switch mode power supply. Good evening from Los Angeles. This is Professor David J. De Los Reyes.